So dear students, for various transport processes, we can write the following relations. First is heat transfer. It is written as J Q, which is equal to minus K temperature gradient dt upon dx. This law is simply called as Fourier's law. Next is mass transfer. It is represented by J with the subscript as small m. It will be equal to minus D. That means the diffusion coefficient and concentration gradient. This is simply called as Fick's law. One more is momentum transfer, which is given the symbol J subscript capital M, which is written as minus mu du upon dx. This is simply Newton's law. And the next is flow of electricity, which is given the symbol JE, which is equal to minus lambda O. So here this flow of electricity, which is written as minus lambda dE upon dx, that means simply the potential gradient, and this is called as Ohm's law. Here these K, D, mu and lambda, these all depend upon the material. Properties of the system. And this JQ here, see here, the JQ, JM, J capital M and JE. These are basically fluxes. So here JQ is called heat flux. JM will be mass flux. J capital M will be momentum flux. And this JE will be electric flux. Electric flux, or you can say electric current. These relations 1, 2, 3 and 4, these are simply called as phenomenological laws. They are basically introduced, these laws, to define simply transport processes. Okay, now we will shift our attention towards the Clausius inequality. Clausius inequality. For example, if you take an irreversible system, that system will basically satisfy this expression, which is delta S will be greater than integral of dq irreversible, and the heat irreversible exchanged with the system, and this is an from A to B. Okay, but for an, if we take now an isolated system, you know, for an isolated system, no heat will be exchanged, no matter will be exchanged, so you can simply write it as dq irreversible will be equal to 0. So if this term is 0, it means this whole term becomes equal to 0. So we can write from this relation delta S will be greater than 0. What is the significance of this? It tells us basically that in an isolated system there is increase in entropy, or we can say a real transformation occurring in an isolated system is accompanied with an increase in entropy. Okay, thank you.